And it's equal to determination of determination of determination of determination of temperature coefficient of resistivity. Determination of temperature coefficient of resistivity. Temperature coefficient of resistivity. Determination of temperature coefficient of resistivity of a metal using Metre Bridge. Of a metal using Metre Bridge. Class ini ada orang lain on YouTube, orang YouTube tu na, kalau otherwise lesson based and question based, paint going on the classes, right? Man, video tu na, kalau mau faham start already you will see. Let's see. Okay, listen. 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 Materials are the same. First, I'm going to the apparatus. About the apparatus, right? About meter bridges and potentiometers, you will be able to draw them, right? Mostly when it comes to questions, right? How you are getting this is an incomplete diagram will be given, and you have to connect other connections with the other missing instruments, missing devices, right? You know anything, but to do it properly, you should be able to draw these, especially meter bridges and the potentiometers, right? Right? If you are drawing the meter bridge, if you are drawing the meter bridge, right? Starting from the copper strips, right? Basic idea, start the meter bridge from the copper strips, right? Copper strips from beyond, starting from the copper strips, like this. That is easier in your draw, right? In the practice, incomplete diagram समझ अरे ये अरे प्रैक्टिस में लगता है और डायग्राम भी कंप्लीट कराना पड़ेगा right? Steps around. Then the main part here, meter bridge wire, right? Main part here, meter bridge wire. Meter bridge wire goes from here to here, right? Right? Doesn't, and when you connect this setup, right? When you connect this setup, doesn't matter whether you are connecting the modified apparatus to this side or that side. Can main software totally fine. Connect right? Everything space area, right? Otherwise, that doesn't matter, right? And make connection is yours. Listen, accumulator, right? Accumulator, switch, and the variable resistor, right? And here there is a fixed resistor and non-resistor, a fixed resistor, a non-one, and the same thing which we have in potentiometer, meter bridge, right? About the galvanometers, like say galvanometers, safeguard resistor, plug key, everything is same. Finally, everything is same here, right? Take it evident. Connections are adding a safeguard resistor, center zero galvanometer with the slider key. And to short circuit the safeguard resistor, we have to have another plug key parallel to the safeguard resistor, right? Safe resistor, that is also called safeguard resistor of Sandaruwan aluminum. Right now, our band is this one. Our band is finding temperature, coefficient of resistivity, temperature coefficient of resistivity, right? Right, temperature coefficient of resistivity, right? That is alpha. There is only one equation we have alpha in the syllabus. What is the equation? R theta equals R naught 1 plus alpha theta. Right? एक और ना हमारा resistance है कौन है? R theta is resistance है theta degrees Celsius. To change the resistance, right? We are using the copper wire here to change the resistance by increasing temperature. One equation I expect by doing this. R theta equals R naught 1 plus alpha theta. This is the only equation we have with alpha. Right, for a conductor, R theta equals R naught 1 plus alpha theta. If there is a semiconductor, that is 1 minus alpha theta. Right, for insulators, no equation. Insulators are the equation stand. Right, for conductors 1 plus, for semiconductors 1 minus. Right, conductors, come equation. Then to change the resistance, right, we are modifying the meter bridge. Now, usually in the meter bridge, what we have is two resistors in these two systems, right? Because usually we use the meter bridge to find an unknown resistor. Right, unknown resistor එකක් වන්න තමයි meter bridge එකේ අර prime curve cell to find unknown resistor. Right? ඒතර මෙතන unknown resistor එකක් ගන්නකොට ඒක වන්න පුළුවන්. Now, since I need to change the temperature of the resistor accordingly, right? The setup is modified with that focus, with that target. Right? Make the temperature වෙනස් කරගන්න ඕනේ. එහෙම වෙන්න තමයි මේ setup එක හදන්නේ. Then to change the temperature, what we do is this. Right? When you heat a metal wire, right? A copper wire, when you heat a copper wire, right? We can't make sure that entire wire is heated if you just heat it by using a flame. No? Then what we do is we are going to dip this, immerse this inside a liquid, right? Usually, coconut oil is used, right? Coconut oil use coconut oil maybe and we are going to wrap this around an insulator like this. Insulator like piece of wood, this layer, and this is wrapped. Wrap like this. The wire. And is connected to this top. And this wire is connected to this top. This is filled with something like coconut oil, right? There are reasons to use coconut oil, right? Coconut oil reasons here, right? And we have to heat this now. You have to change the temperature. To change the temperature, this is kept on a stand tripod, and the burner is used. To measure the temperature, right? We need a thermometer, and to make sure this is distributed uniformly throughout the volume, right? We have to stir, then stir is used, right? When we modification and the wire that you are going to find the alpha is here, right? The wire is here, right? That wire is here. Then you connecting wire switch on. Copper wire. Right. So basically, what we are going to do is this. We know when temperature changes, accordingly, resistance changes. R theta. Resistance at theta degrees Celsius or Kelvin. Degrees Celsius only. Equation chemically use right? Chemically use right? R theta means theta. Theta is the standard symbol for relative temperature. Standard symbol of Kelvin temperature is capital T, right? Capital T. So, body sensor that's why those symbols are right. R theta. Temperature at theta degrees Celsius. R naught. Temperature at 0 degrees Celsius. Not 0 Kelvin, 0 degrees Celsius. Right? Main equation is Celsius. Then alpha, temperature coefficient of resistivity. Right? Theta, temperature or temperature difference. Present temperature. Only present temperature. Right? Thermal equations are temperature difference. Why? We have the 0 degree Celsius here. Difference is nothing. We are going to take the difference with 0. Well, difference that is present temperature or the current temperature. Right? First level. Make an equation. Make an equation. Now, from the equation, now R theta is known. R naught alpha theta. About the meter bridge. By the way, what is the principle of meter bridge? If you ask about the principle used in a meter bridge, what would you answer? 28 days. Principle used in a meter bridge. What then? Online, what's the principle used in a meter bridge? පාඩකලින් ඉන්න කියන්න බයයි කරගන්න දැනගෙන කියන. Online, what is the principle used in a meter bridge? Why well? It's a principle, right? It's a principle, right? It's a it's a right? Yeah. See, what you are doing is listen. What you are doing is after connecting the whole graph, right? I will find the balance point of so at standard rotations. Positive terminal of it is called A, negative terminal is called B, right? And balance point is called C, right? At the balance point, there is no current flows through galvanometer, right? If there is no current flows through galvanometer, which means potential at these 2 points are equal. If no current flows through this branch, right? If no current flows through the galvanometer, right? Which means, according to Wilson principle, right? According to Wilson principle, right? Because principle of meter bridge is Wilson. Alright, because there are no current flows. Now in that case, we have a galvanometer, right? So these can be between A and B, and these points are X and Y. They are R1, R2, R3, and R4, right? If R1 over R2 equals R3 over R4, then Vx equals Vy. This is called Wilson principle, right? This is called Wilson principle. Now in this case, what happens is, if there is no current flows through this, right? Which means these resistors, metal resistor and this one, and there are resistors for the meter bridge wire, for the length AC, right? And this is another resistor, they are known. So these are known. R dash known, R not already. R dash, there is a non-fixed resistor, and there is a resistor for the length CD of meter bridge wire, right? When you know the resistors are 1, 2, 3, 4. If there is no current flows through here, it satisfies the ratio, right? When you burn it, then when you apply this is proved, the equation proved in a meter bridge, right? Let's say this resistance is now R theta, right? R theta, then R theta over, say balance length is L, right? If this length is L, this side becomes 100 minus L, right? Then this one to this R theta L equals R dash to 100 minus L, right? Now, likewise, using the meter bridge, you can find the resistance at a given temperature. Using the meter bridge, you can find the resistance at a given temperature. Say you are starting from 25 degrees Celsius, right? We are starting from 25 degrees Celsius. Then at 25 degrees Celsius, after connecting everything, right? Balancing flame, balance flame, right? Controlling flame, current loading. They are also very because now when you are taking the reading, always you have to make sure that there is at that constant temperature, 25 reading a current loader, right? Or here the system 27 that's some case, right? You are control. They got thermal experiments, right? They got control. Right, then say you are starting at 25 or 25, they are the because L is around there, R dash is around resistor, right? Then once you apply this in the equation, R theta is known, right? The R theta is unknown. We can connect these two, and we can connect these two and find alpha using this, right? Right. When we are output we have plotted out by minimum of 6 values. Right? Connect. Then meter bridge is used to find the resistance of this wire at different temperatures. Right? Meter bridge use kare. Equation එක ඉතින් මේ equation එක මෙන්න මෙතන තමයි feed කරන්න යන්නේ. Using this. This is the meter bridge. Right? Hi. Here was the then why? Now from this subject R theta, subject R theta. R theta is given by R dash L over 100 minus L. R dash L over 100 minus L. Now, if we connect these two, R theta is this no R dash L over 100 minus L, right? Equals R naught plus R naught alpha theta. Now, what are we changing here as the independent variable? What are we changing? What are we changing here? What change? Temperature. Right? When temperature changes accordingly, what is the change in the equation? When the equation we have a finite equation. We are getting about R dash. Constant variable. R dash is a constant. Constant. Let's say R dash is a constant. L is a variable, right? R naught constant. Zero degree show resistance right? And again, over constant. Characterize the given temperature coefficient of ice field. That's the constant. Theta is a variable, and that is what we can change manually. But after we can change, then theta is going to be our x variable. When theta changes, L changes, right? Always to find or to determine gradients, right? We prefer linear graphs. Linear graph that gradient easily curves gradient mirrors use last week mirrors use then always will be prioritizing straight line graphs, right? To plot a straight line, to get a straight line, right? We are going to take this whole thing L over 100 minus L to the axis y and go to rotates, right? And then L over 100 minus L is here. Then this is R naught alpha over R dash times theta plus R naught over R dash. Right. Now this is x. This whole thing is gradient, and this is intercept. This whole thing is y, and the graph you are going to get y plus mx plus c. Right. This is L over 100 minus L. Right. And this is theta. Theta is in degrees Celsius. L over 100 minus L. Right. L over 100 minus L. What's the unit here? L over 100 minus L. No units, right? Then no units, right? Mx plus c. And I'm going to graph mx plus c. And now the intercept is R naught over R dash. And gradient is R naught alpha over R dash. Then how we can find alpha? The graph then the 6 readings are here, graph and then moment the right? What's the easiest way to find the coefficient, temperature coefficient? Alpha go using gradient. No. Why? Gradient on where? Because R naught is unknown. Because R naught is unknown. Even when R naught is known, we don't go to that option. Right? My follow here. Because when we have cancelable variables, right? Always our first priority is cancelling those variables. Right? That's R naught take one that is coming into values. Right? Say we know R dash what the none. Right? Even though this is my known resistor, none of the R dash came out. Right? If you divide gradient by intercept, right? All R naught and R dash both are going to cancel off. Then no error in the calculation. Right? R dash right? Check this is not only limited to this experiment. Right? Right? And in electricity potentiometer That's the thing. I have a gradient intercept. If you are getting the value by dividing gradient or intercept, right? Always our priority is that, right? Gradient again, unknown variables one and that. Okay, then we need alpha. Alpha is given by gradient over intercept. Is alpha, right? So likewise, we can find that. Right. So as an experiment, this is part of a what we call a lengthier one, right? A lengthier one in terms of the details and also in terms of the time it takes to do it. Also, this is kind of a lengthier one, right? We didn't write anything yet, right? No. Okay. First, write down materials, 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 materials. A copper wire that is insulated, that is better. If that is insulated, that is better. Right? A copper wire. A copper wire. Right? Make already know what is SWG. What is SWG? Okay. What is SWG? What is SWG? What is SWG? Make already know what is SWG. Then I know SWG. SWG means standard wire gauge. Then I think we wiring efficiency. Standard level, standard wire gauge. What is the wiring wire? SWG. Standard wire gauge. 40. Right? Okay, wire cell sizes there and 40 kilogram. Okay, diameter value 0.04 diameter. Number right? Wait. Households wire 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 roll length by polymer it was a neutral base analyze body again ඒක කැපුවට පස්සේ ඇතුලේ තියෙන කොපර් එක දැකලා තියෙනව නේද? දැන් දැකලා නැත්නම් ගෙදර ගිහලා ආයෙ ගාලා බලන්න වෙනවා. දැන් ඔක බලන්න ඕනේ. නැත්නම් පොයින්ට් එකට එක බලන්න ඕනේ. අන්න ඒ වගේ ඒක තමයි WG එක කියන්නේ ස්ටෑන්ඩ් වයර් ගේජ් එක 40 කියන එක කියන්නේ ඒක. 40 කියලා කියන්නේ මේ තරතර ලියලා this is called standard wire gauge. නිකන් දැනගෙන ඉන්න මේක SWG කියන එකේ දාලා තියෙන නිසා මේක දැනන්නේ standard wire gauge. Standard wire gauge. Right? Then an accumulator, an accumulator, an accumulator, an accumulator of EMF 2 volts, an accumulator of EMF 2 volts, an accumulator of EMF 2 volts. Right? This is center 0 galvanometer. Right? Next, write down center 0 galvanometer. Center 0 galvanometer. Slide again. Slide again. May keys from the say these keys are this one and this two. What keys are those? Plug the tap the. Huh? Plug it. Plug keys. Right? Two plug keys. Two plug keys. The make it yellow. My plug keys are used. Right? Two plug keys. Two plug keys. Right? It was a resistor box. A resistor box mega and rheostat. A resistor box and rheostat. Even though you use a rheostat, sorry, or a resistor box, right? Mega is a fixed resistor. Right? Mega fixed, fixed until you are doing these fixed. Right? A resistor box and a rheostat. Then Bunsen burner, tripod, thermometer, styler, maybe a collision. Right? Then meter bridge setup කියලා කියන්නේ මෙන්න මේ part එක. meter bridge setup means right the bridge එකේ තියෙන්නේ board එක right with all three streams and the meter bridge wire right මෙන්න මේ part එක තමයි meter bridge එකේ තියෙන්නේ. මෙන්න මේ part එක. මෙන්න මේක විතරයි. Right? And මේක තමයි and everything else you need to set up. Right? You got to set up then there when you start the experiment. නැත්නම් ඒක as a whole you can't take it. Right? 0 ගලවන්න අරගෙන රෙසිස්ටර් දාගෙන හරි ඊට පස්සේ මේ T side දාගෙන ආන එක සෙටප් කරගන්න ඕනේ. right මේ කවර්ඩ් එකේ ගත්තොත් මෙන්න මේක තමයි තියෙන්නේ. the board connected to the strips with the meter wire. right meter bridge. okay and finally connecting wires. right finally connecting wires. for having electricity experiment එකේ මේ connecting wires තියනවාද? ඒක මේ දෙකේ හැම connecting wires තියනවා. එහෙම කියලා ඒ මොකද කියන්නේ ඒක විතරයි. හැම එකකින් connecting wires තියනවා. මේ wires වල ඔය මොනවද කරන්නේ? right then apparatus කියලා මේක ගන්නවා. then apparatus and take down the apparatus. මේ equations කියන්න ඕනේ නැහැ. only the apparatus take down the apparatus. no need to write the equations yet. take down the apparatus. Why are we dividing by r dash? The subject independent variable L over 100 minus L. Why are accumulators used? Accumulators means accumulator scale and that's not the single battery. That is a parallel combination of batteries. Accumulator to get a constant current over a long period of time. Right? We'll see those things in the next part. Take down the right form. Right. When we mention the theory, I want to mention about the Dixon bridge circuit again. Right? If you don't know about the Dixon bridge, right? You can take this down, right? Otherwise, I'm not going to mention about the Dixon bridge separately under theory. Right? Theory instrument theory again. Dixon bridge already already now. Dixon bridge. Right? Right. Label this as label this as label this as copper wire, copper wire, copper wire, copper wire. Here, spiral. This one, thermometer, thermometer. Right? This one, Bunsen burner, Bunsen burner, Bunsen burner. This one, tripod, tripod. Right? And this one, non-resistor, 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 non-resistor. Right. Then theory, theory, theory. Okay, first write down resistance of a conductor. Resistance of a conductor at 0 degrees Celsius. 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 Resistance of a conductor at 0 degrees Celsius is given by is given by put a comma and take down the equation. This one. Put a comma and take down the equation. R equals R naught 1 plus alpha theta. Right? Introduce terms R theta. R theta. Resistance at 0 degrees Celsius. R theta. R theta. Resistance at 0 degrees Celsius. Resistance at 0 degrees Celsius. Right? R naught. Resistance at 0 degrees Celsius. R naught. Resistance at 0 degrees Celsius. Resistance at 0 degrees Celsius. Alpha. Temperature coefficient of resistivity. Temperature coefficient of resistivity. Temperature coefficient of resistivity. That is also called temperature coefficient of resistance, right? Alpha, temperature coefficient of resistivity. Resistivity equals resistance equals our plan. In signal time also that's same like that. Shakti प्रतिरोधकता संग्रह के ना मैं प्रतिरोधकता तावे संग्रह दिखाता हूँ यहाँ पर. Right, then theta present temperature. Theta present temperature. Present temperature. Right, make a difference. I mean, that's a important thing. Make a difference. I mean, otherwise, now as thermal expansion equations, right? Even though it has the same shape, but here we have something at 0 degrees Celsius. Right, the initial one, right? Initial value is 0. And that's why here is the present temperature. Present temperature. Right? Okay, then try down below. If balance length, if balance length, if balance length, if balance length of meter bridge, if balance length of meter bridge is simple L, if balance length of meter bridge is simple L, if balance length of meter bridge is simple L, put a comma. Then here mention this as at balance point. Earlier at balance point. At balance point, mention this R0 over L, R0 over L equals R dash over unlimited. And subject R theta, and subject R theta, subject R theta. Subject R theta. Subject R theta. Right? Then right on. Using equation above. Using equation above. Using equation above. Combine this two now. For R theta in this equation, plug from here. Right? Then also here. Start from here and prove it up to this point. Right, prove it up to this point. Y equals mx plus c. Right, then cut the graph, cut the graph, cut the graph and mention this also. Right? From that, the theory part is over. Right? Graph and make sure you have labeled axis. This axis is unitless, right? That's why unit is mentioned. Length over length, that is the ratio, that is unitless, right? This is in degree Celsius. Finished? Right. Doesn't know? Now before explaining method, right? Method now explain another. Right? Listen. Now basic idea about Metre Bridge and using the Metre Bridge should be known, right? Then we have plan. Anyway, right now, before starting any experiment, using Metre Bridge or potentiometer, right? They got a common level. A common level, right? Before starting any experiment using Metre Bridge or potentiometer, right? You have to keep the criteria A and B respectively and check whether 70 kilometer deflects from one side to the other, passing zero, right? Opposite sides are unknown, right? If there is deflecting to opposite directions, right, which means you have a balance point in between, right? If there is not deflecting, passing zero, right? Passing zero, which means you are not going to get a balance point, and there are reasons not to obtain balance point in such cases, right? We'll see what they are in the next part, right? First part we are doing is keeping the side here A and B respectively, right? Positive area, negative area at A and B respectively, and I have to check whether 0 galvanometer deflects from one side to the other, passing zero, right? Then initially, listen, initially, we close only switch S1. Listen, initially, we close only switch S1, right? Keeping S2 open. When S2 is open, when current passes through the galvanometer, it passes through this resistor. When the switch is open, right? It's a safeguard resistor. Safeguard resistor is to safeguard our galvanometer, because galvanometer is very sensitive, right? Meters are very galvanometer, they are very sensitive, right? So therefore, initially S2 is open, only S1 is closed, right? And then by keeping this open, first you are going to find the rough balance point, right? Again, there are rough balance point of power. That is called a rough balance point, right? Once the rough balance point is known, you know around which length that you are going to obtain balance point, right? Like a water, gila, side gear, or look current and passes and it both galvanometer, right? It burns out. Galvanometer gear pass I have another way, coil, I have done, right? I have galvanometer, you right? I other right? It has a small Coca-Cola inside, right? Feature it all will have the writing which one galvanometer and take a manasa. Here I am making, right? Then first you are getting an idea about the rough balance point, and then then we are closing S2 also. When S2 is closed, this resistor is going to short circuit. Right? Then current passes through this. Alright? Next outside. And then you are going to find that exact balance point. Right? Well, balance point is already out of map because close to the balance point, only a small current close to. Anyway, close to the balance point. That's like what again, experiment one and because the real one, there one kilometer. Right. The area of the line, alright. Then you have to find that balance point. And at the balance point, have to take the reading of balance length, right? Balance length, and from the thermometer, have the temperature reading. Say you are starting at 25, right? 25 will start thermometer. Minimum reading at 60 readings. Then right, this has to be recorded. First temperature 1, 2, 3, 4, 5, 6. Right? Say you are starting at 25, 25, 30, 35, you know, very unloaded. 40, 45, 50. Right? And for each temperature, right, balance length is going to differ. Right? Then you will get 6 different balance lengths. Maybe right, this is in centimeters. If L is known, then you can find L over 100 minus L. Yeah. Right? So, next one right? This is a group work. It's a group work. Start correcting node. Right? Because mega read correcting node. Temperature control correcting node. Right? Because balance point check in node. Right? Minimum other company node. Other group work right? Right, so likewise, listen to that. Likewise, you have to find the balance point, right? And repeat the same for 6 different readings by changing the temperature by changing the temperature by partial load. Right? When we take a reading at a given temperature, right? We have to make sure that the system remains at that given temperature until you finish taking the reading. Right? For that, the flame should be controlled. Flame family or right? To control the flame, you are taking the Bunsen burner out of the driver and again putting it in, right? Take a cup and tawega from the thermal. Right? And the other thing is you can increase the temperature of the system like 1 degree Celsius or 2 degrees Celsius above the value required. 25 and then अब मेरे 27 वगैरह का heat करना. It was a color Bunsen burner का आई करना and let it cool down and go to the reading at 25. So देखो करंट को बोलो, तो देखो जाने की मतलब right? Well, they have one thermal view. Connections are only. They have one thermal view. Okay, then go to mirror. 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 Okay, right now, first point. First point. Connect the circuit. Connect the circuit properly. Connect the circuit properly. Connect the circuit properly. As discussed under apparatus. As discussed under apparatus. Connect the circuit properly. As discussed under apparatus. Right. Next point. Next point. Close switch S1. Close switch S1. Close switch S1. And keep S2 open. And keep S2 open. Keep S2 open. Next point. Next point. Keep slider key. Keep slider key. Keep slider key at A and B respectively. At A and B respectively. at A and B respectively. Keep side D at A and B respectively. And check the reflection of center zero galvanometer. And check the reflection of center zero galvanometer. And check the reflection of center zero galvanometer. Whether it passes through zero, from one side to the other. Whether it passes through zero from one side to the other. Whether it passes through zero from one side to the other. Whether it passes through zero from one side to the other. Next point. Record initial temperature. Record initial temperature. Record initial temperature. Record initial temperature. And find the rough balance point. And find the rough balance point. And find the rough balance point. Rough balance point. Next point. Now close switch S2. Now close switch S2. Now close switch S2. To short circuit. To short circuit. To short circuit. To short circuit. Safeguard resistor. To short circuit. Safeguard resistor. Short circuit. Safeguard resistor. And find the accurate balance point. And find the accurate balance point. And find the accurate balance point. Record. Temperature and balance length. Record temperature and balance length. Record temperature and balance length. At this instance. Repeat the same for at least 6 different readings. Repeat the same for at least 6 different readings. 6 different readings. And record respective theta and L. And record respective theta and L. And record respective theta and L. Record respective theta and L in following table. Record respective theta and L in following table. Take down this table. Theta and L in following table. Take down this table. Right? Right. Next point. Next point. Cut the graph between. Cut the graph between. Cut the graph between. Cut the graph between L over 100 minus L and L over 100 minus L. Cut the graph between L over 100 minus L and theta. And theta. Next, beta y. Beta y. Next, beta y. Next point. Beta y. Alpha. Beta y alpha. Using gradient and intercept. Using gradient and intercept as discussed under the beta y and alpha. Using gradient and intercept as discussed under the right. That's it. Right. That's it. And again here also, right, there are right important points, remarks that you need to know about this, right? Maybe the method now you know what the materials are, riders, right? And you know the theory used behind this, the logics, right? And finally, now the method is done, which means experiment is all done. But we have discussed the other remarks here at last, right? Then finally, remarks. 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 The point. No balance point is obtained. Under remarks. Under remarks. First point. No balance point is obtained. 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 If center 0 galvanometer, if center 0 galvanometer, if center 0 galvanometer does not deflect, does not deflect, does not deflect from one side to other. When slider is kept at A and B, when slider is kept at A and B, right? The reasons to happen so is right. Mention reasons. Mention reasons. First one, loose connections, right? Loose connections. Again, may have that. Maybe have wires. Abhi connected. The loose connection and how. There are loose connections. Loose connections. Right. Listen. Right. So first thing, now මෙහෙම case එකක් වුණොත් meter bridge එකේ යද්දී right meter bridge එකේ resistance වලින් එහෙම issue එකක් වෙන්නේ නැහැ. meter bridge එකේ resistance වලින් issue එකක් වෙන්නේ නැහැ. But when it comes to potentiometer also we are doing the same practice. A to B and A and B check කරනවා. check කරලා පස්සේ එහෙම වුණොත් ඒක නම් secondary circuit එකක් තියෙන secondary circuit එකේ issue එකක් වෙන්නත් පුළුවන්. But here you don't have a secondary circuit. Then you insert වලින් right. So probable reason is a loose connection. Loose connections තියෙන පුළුවන්. Fine. Then the other thing is about this about using safeguard resistor with this plug key, right? And what's the reason to use plug keys now? Yeah, there are. Kali mage tap here compare करना. Why you have to plug keys now? Now we need to have continuous current, right? Maybe temperature current is right? And to make sure the current is steady and current is constant, we are using an accumulator. Maybe a cell use right? That's why accumulator is used. Usually, accumulator in laboratories, a motorcycle battery. Motorcycle battery is take a cells right? That's cells means cells motorcycle battery व्यवस्था मोटरसाइकिल बैटरी का बैल में दान क्या सेट करवा ना मैं हाँ बैटरी का कोई भाई एक का मिनी बैटरी का करो अरे हाँ बैटरी को बैल में दान तो और रिसर्च करना मैंने एक का मिनी वर्जन ना कोई मैं एक ये सेल्स था they are parallel cells right so we know when we connect cells in parallel combination always EMF remains unchanged EMF remains unchanged के लिए average नहीं मतलब equivalence हम equivalence क्या but E can have level then equivalent to E here, right? Only advantage you get is right. You can have a constant current, a steady current for a long period of time. Take a long accumulator use that. Accumulator can battery and then you got a dry cell layer, right? Accumulator के लिए क्या है? Dry cell layer तो लैब पे क्या है accumulator का use कराने में क्या accumulators के ना होते हैं आप बेटा accumulators होना हमारा ना पूरा using हमारा chemistry दी हमारा अन्य है हमारा पूरा accumulators electrochemistry aramatin emak पदार्थ बोलो आप लैब पे के use कराने में मोटरसाइकिल बैटरी right ये है ना आयो आप लैब पे के use करें मोटरसाइकिल बैटरी बड़ी मोटरसाइकिल बैटरी right बड़ी क्या 12 volts है okay then next point write down next point write down buckets are used 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 since we need a continuous current flow 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 throughout the experiment since we need a continuous current flow throughout the experiment next point an accumulator is used and accumulator is used and accumulator is used an accumulator is used to provide a steady current flow throughout a steady current flow throughout the period to provide a steady current flow throughout the period right so the next thing when you wrap this around this wooden piece right when you wrap this around the wooden piece right, you have to make sure that they are not in contact because if they are in contact the wire is going to outside right the wire के mega equivalent में पहले outside right and if that wire is an insulated wire right if that wire is an insulated wire that is better right not to short circuit but when the wire is insulated even though our temperature of the liquid here is right at say 25 right it takes much longer to reach to 25 by the wire the wire का insulated का तिब्बत right ये मैं प्रश्न होती है ना अगर insulated का तीन होता है यार like pros and cons insulated का the short connections in में short circuits in right insulated का आता तब करना ले right next point wire turns should not be in contact with each other wire turns should not be in contact with each other wire turns should not be in contact with each other else, else, it should be covered with an insulated cover. Else, it should be covered with an insulated cover. Else, it should be covered with an insulated cover. To avoid short circuits, to avoid short circuits, to avoid short circuits. Right. And this one, very important. As a liquid we use here, right? As a liquid, right? Most commonly what we use here is coconut oil. Right? As a liquid here, what we most commonly use is coconut oil. Right? Label this as coconut oil. Coconut oil. Coconut oil. Coconut oil. Right? Why coconut oil? Okay, questions are the why we are using coconut oil or glycerin, glycerin pula, right? Common name is coconut oil, sir. Glycerin oil, coconut oil, easily calculable, right? So most commonly, coconut oil is used over water. Question name why coconut oil is used without using water? What are the reasons? What are the possible reasons? There are also possibility of conducting current through water, right? Bubble current right? It's two way one thing is that front plane with the power cut කරන්නේ ඒක හිතලා කට් කරන්නේ power cut කරන්නේ නැත්නම් මිනිස්සු ගමන් වලට නෙවෙයි මුන් කරන්න බදලා ගන්නවා අය අපි ගන්න එක ගමන් වල බහින්න ගියා සීරියස් එක කරන්න බදලා ගන්නවා හරි ඒක හිතලා ඩිස්කනෙක්ට් කරන්න නැත්නම් අරගෙන පුළුවන් ඉතින් බය කියන්නේ වින් කියලා ගන්න හැමෝම හරි එතෙන්ට පිළිලා නැත්නම් බය ඩිස්කනෙක්ට් කරනවා අනිශ්චය මොකක් හරි ලීකේජ් එකක් ගාවොත් නැත්නම් අර ෆ්ලඩ් එකත් එක්ක වදිනවා යාල් වලින් එහෙම ඔක්කොම ෆ්ලඩ් වෙනවනේ ඒතකොට නිකන් මේ ප්ලග් පොයින්ට් එකකින් උනත් කරන්ට් එක ලීකේජ් කරන්ට් එකක් එන්න පුළුවන් ඒ නිසා මුළු ඒරියා එකම ඩිස්කනෙක්ට් කරනවා right so one thing to use coconut oil is water conducts current whereas coconut oil does not conduct current right එහෙනම් මෙතනින් මෙහෙම current pass වෙන විදියක් යනවා නැත්නම් මේ කොයිල් එකේ මෙහෙම current pass වුණොත් මේ වැඩේ හරියන්නේ නැහැ නේද මේක දැන් මෙහෙම කොතනද මෙහෙම current එක pass වුණොත් right so the current spark it should spark to the surrounding medium right that's why surrounding medium is being coconut oil okay guys and the next option is if you are taking these readings for a higher range right for a higher range right there's another chance from coconut oil because boiling point of coconut oil is higher than that of water right boiling point of coconut oil is around 160 170 usually 170 again around 170 coconut oil වල boiling point එක වැඩි ඒ හින්දා අපේ readings මේ වගේ නෙවෙයි තව ගොඩක් වුණා ඉස්සරහට ගන්නත් පුළුවන් right 100 වලින් එහාට ගන්න පුළුවන් otherwise if you use water right definitely you have to stop before 100 right 100 වලට තියා ඊට පස්සේ boiling point එක reach කරනවා ඒ හින්දා කරන්න වෙන්නේ නැහැ නිසා coconut oil වලින් use කරනවා તો glycerin also there is same glycerin වල 160 170 range එකේ තමයි boiling point එක and එතනක features එක coconut oil use කරන්නේ ඒක හැම කෙනෙක්ම තියෙන හින්දා දැන් ගානේ ඉතින් ආගල් ලේසි right glycerin left එක තියෙනවා අතයි coconut oil තියෙනවා right then right on this point coconut oil is used coconut oil is used coconut oil is used coconut oil is used without using water in the vehicle without using water in the vehicle without using water in the vehicle right mention reasons reasons के अलग mention reasons first one coconut oil is a weak coconut oil is a weak current conductor coconut oil is a weak current conductor weak again it's almost no right it's a weak current conductor so there won't be any short circuits So there won't be any short circuits. So there won't be any short circuits. Right, next point. Next point. Readings can be taken even up to a higher range. Readings can be taken even up to a higher range. Readings can be taken even up to a higher range. Readings can be taken even up to a higher range. Even up to a higher range. Since boiling point of current oil is boiling point of current oil is around 170 degrees Celsius. Around 170 degrees Celsius. Around 170 degrees Celsius. Right? Okay. We know there's a heating effect of current, right? Why we don't use current itself to heat this without using this alarm? Okay, question not about because current itself has a heating effect, right? Current has the order of right? Then when current flows, this copper wire itself heated, right? Then without using these Bunsen burners, these things, right? What if we use that current which flows through the conductor itself to heat this? Temperature right? These are possible questions that can be asked, right? Reason is this. Now, when you increase the current, you increase this, right? All the temperatures here, all the conducting wires, all these copper strips, everything is heated. There's a system of heater. The memory system of heater. मैं meter bridge वाले के इनाम में हम क्या नाम resistor थे ना sorry meter bridge वाले क्या conductor है ना मैं copper strips क्या conductors हमें क्या नाम conductors है तो ये कौन में इक्वेशन follow करता हूँ right तो ये मैं अब बात करने लगा तो सेवा वो system में resistance है ना सर that's going to be a mess right ये बात आप लोग ऐसा current again पता है that's a main reason if you are to do this by using current somehow. Okay, external current है कर दिया तब क्या निकल गया मैं current को करा दूं मेरा external current है लिया मैं तुरंत ये भी आपका निकल गया but again the thing is it can be controlled then मेरे पास flame में control करना right then current can be controlled as this remains at a constant temperature right and to heat it to this kind of temperature right we need a massive current right and normal में milliamperes वगैरह current का flow होना लिया आता विचलन आता नहीं है right मैं क्या Thirty conductor temperature there temperature 30 right 35 kilo yeah this amount there no there 40 kilo there right hema after that चलो लोगों की dissipation ना कितना पूरा milliampere करना right hemi dissipation ना करना लोगों current flow करना है right that is impossible right hema current है यानी यहाँ kilo amperes वाले current flow करना है ना amount right higher ampere value का करीब और kilo ampere value Jadi cara harian na udah me lupa anda kian anda muka anda kian anda orang ibu reason sulung dia no main reason is that everything is going to be that if you follow current through the main circuit ना मैं मतलब ना current flows ना they are not heat करना okay next write out right यहाँ पे questions आम हो गए इधर आओ next write out current flows through copper wire can be used. Current flows through copper wire can be used. Current flows through copper wire. Current flows through copper wire. Current flows through copper wire can be used to heat the wire. Can be used to heat the wire. Mention reasons. Mention reasons. First reason. All conductor parts in the circuit. 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 Gets heated. and their resistance and their resistance and their resistance varies and their resistance varies. Right? Next either. Next either. Current cannot be controlled. Current cannot be controlled. Current cannot be controlled. Current cannot be controlled. To keep the wire at a constant temperature. To keep the wire at a constant temperature. Right? Next one. Next one. Comparatively, very high current is required. Comparatively, a 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 very high current is required. A very high current is required to heat the wire. To heat the wire sufficiently. To heat the wire sufficiently. Right. Next point. Next point. Write down. A liquid is used to. A liquid is used to. A liquid. Liquid and a Bunsen burner. A liquid and a Bunsen burner is used to. A liquid and a Bunsen burner is used to. A liquid and a Bunsen burner is used to. Make sure the entire wire part. Make sure the entire wire part is heated to the same temperature. 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 And to keep the system at a required temperature. To keep the system at a required temperature. To keep the system at a required temperature. For a small time interval. For a small time interval. For a small time interval. Until a reading is taken. Until a reading is taken. Until a reading is taken. Right? Next one. Next one. Following methods can be followed. 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 Can be followed. To keep the temperature of system constant. To keep the temperature of system constant. To keep the temperature of system constant. Until. To keep the temperature of system constant until the reading is taken. Right. First one. Controlling flame of Bunsen burner. Controlling flame of Bunsen burner. Controlling flame of Bunsen burner. Right. Second one. Increasing temperature to a higher temperature. Increasing temperature to a higher temperature. And let the system cool down. And let the system cools down. And let the system cools down. And take a reading. And let the system cools down and take a reading. and let the system cools down and degrade. അപ്പോൾ thermal വലുത് Q ആ thermal ഒക്കെ correct ആണ് thermal വലുത് Q ആ controlling flame and increase temperature 27 ഇവിടെ 25 വരെ ഇതര റീഡിംഗ് ആണ് right അതാ പിന്നെ അപ്പൊ ഈ ഫ്ലെയിം 25 വരെ ആരെങ്കിലും വാങ്ങിക്കോ ആ റീഡിംഗ് ആണെങ്കിലും മെയിൻ ആവുമ്പോൾ ഇപ്പൊ ഹീറ്റ് പാർട്ടിക്കിൾസ് ചെയ്യണം ഈ എന്തെങ്കിലും ടെമ്പറേച്ചർ കഴിയും right so either I will take the reading right the system might not be at 25 maybe 25.5 25.8 26 वगैरह देखो right to eliminate that error these two output right okay so that's it about this one and this is again a very popular experiment right you can mistake questions check करवाना पहली बार क्या लेते हैं experiments that take नहीं right a very popular experiment when it comes to the structure is this right okay, any questions? Any doubts? Any questions or doubts about this? Regulators, tube, cylinder, current, and rise to just exactly. Okay, now the button username. Okay, right. Any questions? Am I too fast? When I read out points? No. I am on. Yeah, points can. And then can you reduce the speed? Yeah, man. I was slow to read. Right, now whether we are speed. Okay. Mama, idea करने किसी का आई क्या कर रहा है? उनकी idea रहा है वो क्या रहा है? Okay. Yeah, yes. Is it clear now? Clear. Yeah. Clear. Comparison of cells comparison of EMFs. Is it clear now? Okay, then we'll go on. Experiment 3. Experiment 3. Experiment 3. Make it go on. Nikam bahan dia yang lagi and the detached on figure I possibly recording easier temperature so whatever and then ये बोल गया ज़्यादा देखते हैं अभी क्या क्वेश्चन था ना आई पकड़ोई लोग ये ना right anyway after point next class switch it when open accurate balance point measure and record length then we the board wires right. When you I discussed the areas mentioned the first, we're going to avoid this obtain standard value of data from data book and type. Not when I want maybe a keyboard. This one. When preparing the coil of wire, take a cylindrical piece of wood about 10 centimeters in length and diameter about 2.5 centimeters and insulated copper wire 40 WGS of about 5 meters in length. Bend the wire into a double thread and wrap it around piece of wood as shown in figure. Why we are using a double thread? But they want figure. Why a double thread is preferred? Double thread के ना the insulated wire and threads के वाला काम है double thread कर ला ता what's the reason? What can be a reason? क्या इधर क्या? What can be a reason? When we have a higher length for the wire, we have a higher resistance. Higher resistance, the values you are going to get Right, the values you are going to get here are significant considerable values. Right, නැත්නම් පොඩි පොඩි values එක lengths වලට. ඒ වුණාම percentage errors වෙනවා. Right? Right. මේකේ දෙන්නේ 5 meters වගේ වාරයක් ගන්න කියන්නේ 5 meters වගේ වාරයක් එකක් එතකොට දැන් track කරන්න යන්නේ. දැන් මෙන්න මේ වගේ length එකකට. Right? එතකොට මේක double කරලා track කරන්න කියලා කියන්නේ ඒක. Always when you use multiple colors, right? Always you can have a higher length. එතන higher length එකක් තියෙන එක හොඳයි. It is higher length එකක් තියෙන එක හොඳයි. Because then you can get considerable resistance values. Resistance value එක considerable එකක් එනවා කියලා කියන්නේ යාට comparatively. හොඳ value එකක් එනවා. නැත්නම් වෙන්නේ මොකද? Otherwise, if this value is too small compared to this, right? This is a common defect we have in a meter bridge, right? If this value is too small compared to this, right? Your balance point is going to bias somewhere here. මෙතන පොඩි balance length එකක් එනවා. Right? When you get a smaller balance length, percentage errors of that readings are very high. Right? That's why it is advised to use a lengthier wire card. Right? ඒක length එක තාම වැඩි කරන්න පුළුවන් එක මේක දාන්න තියෝ මේක double කරන්න අවශ්‍යයි. That's why this double string is preferred. Right? double කරන එක තාම දෙන්නේ. Okay. Right. Let's move on. Go to experiment 3. Here. Right. Go to experiment 3.